Hello, today we will discuss how the test that we can perform in our circular facade lab to research the challenges related to the end-of-life phases of the facade products in order to close their loops. Prototypes or mock-ups are commonly used in facade product development either to understand the performance of an innovative product in specific boundary conditions or to check the final aesthetics of a facade. Within the Fusion Grant Research Project, we decided to use prototypes and experimental tests to confront alternatives of facade product designs to understand which alternative was the one with the biggest reusability potential. The design alternatives consisted of different connectors of the core layers of a prefabricated timber frame facade. First prototype represented the state-of-the-art with staples. The second prototype had instead screws. The third one, timber nails, and the last one had no connectors but geometrical dry assembly. We asked to the manufacturers of the prototypes to perform both extraordinary maintenance activities by temporarily dismounting the enclosure panel of the timber frame facade and end-of-life disassembly activities, trying to recover as much material as possible for a future reuse. Both tasks were asked to be done in a reasonable time, and we monitored the time and the material that could be reused at the end of the activities. The results demonstrated that the state-of-the-art connections, the staples, are the fastest options to manufacture, but also the slowest options when the components of this facade system need to be removed in an extraordinary maintenance activity or separated when they reach their end of life. Fixing the enclosure of the timber frame with screws could be useful for a future reuse of the panels if the same holes are used in a second fixation stage. Yet, the disassembling of elements remained time-consuming. Timber nails showed overall better results, their production time being almost comparable to the staples. They are easily separable when reaching their end of life and needed a reasonable time in an eventual extraordinary maintenance activity. The best option to ensure a fast and effective extraordinary maintenance was, as expected, the facade with the geometrical assembly and no connectors. However, it was also the most time-consuming in terms of its fabrication, and the facade with the timber nails had similar disassembly times than this option. Visual check of the facade components after the substitution and the disassembly activities was essential to understand the reusability potential of the different types of connection of the four facades. When disassembling the facade with the staples, part of the material was lost, such as the internal finishing plasterboard and the borders of the OSB and medium-density wood fiber boards, which were cut for a faster disassembly process. Moreover, part of the plaster remained attached to the wood mullions. On the contrary, when disassembling the facade with no connectors at all, panels remained, of course, complete and free of damage. Only part of the waterproof membrane remained attached to the mullions. Regarding the facade elements with screws and timber nails, they were separated without harming them, except from the holes of the connections that, of course, remained there. We also use this testing approach to other research prototypes to learn more about challenges of current facade products when closing their loop.
For instance, we disassembled another benchmark timber frame facade which had integrated a window. And the assessment revealed that the current design has significant room for improvement of the disassembly process. For example, one significant issue that hampered a full disassembly with no harm was that some layers avoided the access to other layers. For example, a screw fixing the frame was then covered by another row of strips.
We also disassembled the window components, and then the most challenging part of the test was to get the window element without contamination, or let's say clean. The use of silicone, tape, adhesives and so on was the main reason for that.
Yeah, so each facade element and component have their own challenges when closing the loops at the end of life stages, and we should have a techno-economic approach on it. So while meeting current standards for robustness, rigidity, thermal performance, airtightness, and so on, it's essential for sure. But we should also start considering effective disassembly should be added to these requirements to find suitable circular solutions.
Is that for this reason that we offer the service of our circular lab to facade manufacturers, construction companies, so they can test in practice with mock-up their product. They can carry out disassembling tests, and by assessing the circularity of their product based on the possibility second life scenario, they can really understand how to improve their products.
Still, we are researchers continuously improving our methods, and as part of the future research, we should include aging methods to the end-of-life tests in order to have more accurate representation of the end-of-life of the facade products.
We should also improve the disassembling tools and the processes, of course.
We will work on that.
Exactly.